Hi, this is example 4 from exercise 6.02, and in the previous chapter 6.01 we were using graphs to solve simultaneously. This time they asked us to do it algebraically and use substitution. In an exam, if it just says solve the following simultaneous equations, it's up to you. But if they say solve using algebra or solve using substitution, by substitution, you must use the correct method. So let's have a practice. You've done this before, I know, I can remember that you do it in year 10. So it should be fairly familiar. We've got a couple of equations. We've got x plus 2y equals 23 and y equals x plus 4. Now, they've been really kind to us and given us this y equals x plus 4. It's already there. So what I can do is everywhere there is a y, I can substitute in the x plus 4. So let's go and have a work with equation 1, and we'll try substituting in equation 2. So using equation 1, this is shorthand for equation 1. Substitute equation 2, y equals x plus 4. So everywhere I see a y in equation 1, I'm going to substitute, I'm going to put in the x plus 4. So let's write out the equation to start with. X plus 2y is equal to 23. Now, x is x plus 2 lots of, now there's the y, so instead of writing y, I'm going to write x plus 4. So I have 2 lots of x plus 4. I might just take that multiply out, you don't really need it. I'll just neaten that up again, plus 2 lots of x plus 4. And that's still equal to 23. So let's expand first. We'll do, we can't do anything in our brackets, but we can use the distributive law. 2x plus 8 is equal to 23. 1x plus 2x gives me 3x. And 8, I can take 8 from both sides. So 23 minus 8 is hurting my brain. That gives me 15, yeah? To get x by itself, x is equal to 15 divided by 3 is 5. All right, so I think that the x value for this is x equals 5. So now I can use this value, x equals 5, to substitute back into the equation 2 and see what the y is equal to. Substitute. Anyway, you know what I'm trying to write. Substitute x equals 5 into y equals x plus 4. That's equation 2. So I'm just going to slide up a bit. So y equals x plus 4. I've just said that x is equal to 5. I've just worked that out. So 5 plus 4, y is equal to 9. Now, I do need to check. So, sorry, go back. The most important part, the solution for equations x plus 2y equals 23 and y equals x plus 4 is that combination. Dun, 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 dun. 5 and 9. All right, so that's not the end of it. You have to check. So let's check. Do the check. Let's substitute 5 and 9 into equation 1 and see if we get the right answer. We choose equation 1 because this one was quite simple and it wouldn't be as good a check into that one. So let's check. Substitute 5x equals 5 and y equals 9 into equation 1 oops, where am I writing to now? Into equation 1 and check it out. So equation 1 was x plus 2y equals 23. X plus 2y equals 23. But we know x is equal to 5 and y is equal to 9. So 2 lots of 9 is that going to be equal to 23? Let's see. 5 plus 2 9s are 18 is equal to 23. Yes. Does it work for the other one? We can already tell 9 is equal to 5 plus 4. So the left-hand side equals the right-hand side. Tick. So it is true for both. So there is a method on page 243. This method is written down. So make one of the equations equal to a variable. Substitute this into the other equation. Solve. Use your answer to find the other variable. So in our case, we had y was equal to x plus 4. And then we found the x. Then we substituted it back in and solve for the y. Then we need to check. So those are the steps, and we went through each of them. Come back over here and see. We didn't need to rearrange anything. Luckily for us, the equation was quite nice. It was already there. Y equals x plus 4. I didn't have to rework anything to get it in that format. It came like that. So I used this to substitute the x plus 4 into the equation. Then, when we found that x was equal to 5, we put it into the other equation. And we solved for y. So we found x, then we solved for y. And then that gives us our x and y for our coordinate change of 5, simultaneous coordinates of 5 and 9. We put those then and check them